Hey everyone, in this video we'll learn how to use the quadratic formula to solve any quadratic equation. So just like in the previous video where we learned how to complete the square, in this video we will learn how to solve any quadratic equation at all by using the quadratic formula. So first let's write down what the quadratic formula is. So for any quadratic formula, what we're trying to find is x. That is the variable that we try to solve for in any quadratic equation. And the quadratic formula to solve for x in those quadratic equations is x equals negative b plus minus the square root of b squared minus 4ac over 2a. And that's the quadratic formula. So let's go ahead and test it out. So let's say we had this quadratic, x squared plus 7x plus 6 equals 0. So the very first step is to make sure that it's in ax squared plus bx plus c equals 0 form. And as you can see, it already is in that form. We have our ax squared right here, ax squared plus bx plus c, and it all equals 0. It's all on one side of the equal sign. And let's write down what our a, b, and c are. So our a equals, so right here there's no coefficient, so that's always a 1. So our a is 1. Our b, so our b equals 7. So you can see right here it's 7. And our c is just 6. So c equals 6. And the next step to using the quadratic formula is to just substitute all these numbers. We have our a, b, and c. We can go ahead and plug it into this quadratic formula. So let me actually rewrite this quadratic formula just so we have all the right colors. So our b is right here. So b, and our a is in blue. So let me just replace that. So a, and our c is in green. So let's go ahead and replace that. And again, this is our quadratic formula. X equals negative b plus minus the square root of b squared minus 4ac all over 2a. So let's go ahead and use it to solve this quadratic that we came up with. X squared plus 7x plus 6 equals 0. Okay, so let's go ahead and begin by substituting it. So let me actually just move this down here, just so we can get a better look at it. And let's go ahead and begin substituting. So x equals negative, and what's our b? Our b right here is 7, so negative 7, plus minus the square root of b squared. So what's our b? Our b is 7, so 7 squared, minus 4 times, and what's our a? Our a is 1, times c. And what is our c? That is the 6 right here. And this is all over, so this is all divided by 2 times a. So 2 times a, and our a is 1, as we said up here. Our a is 1. So 2 times 1. Excellent, so let's begin evaluating. So x equals, okay, so we have negative 7 plus minus, and let's evaluate what's inside this radical. So what is 7 squared? 7 squared is 49, so radical 49 minus, and what's 4 times 1 times 6? So 4 times 1 is 4, and 4 times 6 is 24. So 24 all over, and what's 2 times 1? 2 times 1 is just 2. And let's keep going. So we can evaluate this 49 minus 24. That gives us 25, so x equals negative 7 plus minus the square root of 25 over 2. And right away, what does the square root of 25 evaluate to right here? The square root of 25 is simply just 5. So 5. Okay, and we're almost there. Now let's go ahead and split this up because we have this plus minus symbol. So we have this plus minus symbol. So what that means is we're going to split it up into just two equations. So x equals -7 plus 5 all over 2. And x equals -7 minus 5. So minus 5 all over 2. So let's start with this one. What's -7 plus 5? So -7 plus 5 is -2. Let's write that. And what's -2 divided by 2? That is -1. Now let's evaluate this. What's -7 minus 5? That is -12. So -12. And what's -12 divided by 2? That is -6. And those are our two solutions. X equals -1 and x equals -6. And there we go. That's how we use the quadratic formula to solve any quadratic equation. And again, this is the quadratic formula right here. It states that x equals -b plus minus b squared minus 4ac over 2a. Now there's one more thing that's important to know about the quadratic formula. It's that this radical right here, the square root of b squared minus 4ac, so the radicand itself, b squared minus 4ac, let me write that down. B squared minus 4ac. This has a special name. This b squared minus 4ac in the quadratic formula, this is called the discriminant. And it's very important. The discriminant. The discriminant. B squared minus 4ac. And the reason why it's important is because the discriminant tells you a lot about what type of solutions to expect from the quadratic. So let's go back to this, this quadratic right here, x squared plus 7x plus 6 equals 0. What's the discriminant of this? So we said the discriminant is b squared minus 4ac. So let's go ahead and write that down. So b squared minus 4ac. So let's go ahead and substitute. What's our b? Our b right here is 7. So 7 squared minus 4 times, and what's our a? Our a is 1. And then times c, what's our c? Our c is 6. Let's evaluate this. So 7 squared is 49. Good, so 49. And minus, what's 4 times 1 times 6? So what's 4 times 1? That's 4. What's 4 times 6? That's 24. So 24. 49 minus 24 is 25. Okay, so 25 is our discriminant. So the discriminant is 25. And what does that tell us? So our discriminant tells us what type of solutions we expect to see. And this is very important. So let's go ahead and scroll down a little bit. So let's draw a little table. So the discriminant and solutions. So if the discriminant is a positive number and it's a perfect square, then there are two solutions and they're rational. There are two rational solutions. And that makes sense because the discriminant up here, our discriminant was 25. So 25 is a positive number and 25 is a perfect square. So since 25 is a positive number and it's a perfect square, that means we have two rational solutions. And that's true. Look at our solutions. We have x equals -1 and x equals -6. Those are two solutions, and they're both rational numbers. So we have two rational solutions. Two rational, so let me write that again. Two rational solutions. Good. What if our discriminant is positive and it's not a perfect square? So not a perfect square. Then you will have two irrational solutions. You'll still have two solutions, but they will be irrational numbers, meaning there's a radical involved somewhere. So that's what happens if your discriminant is positive and it's not a perfect square. So just a quick example, let's say we had this quadratic x squared plus 5x plus 2 equals 0. And what is our discriminant? So b squared minus 4ac. So that's our c, that's our a is 1, and that is our b right here. So let's solve this quickly. B squared, so 5 squared is 25, minus 4 times 1, which is our a, times c, which is our 2. And what is 4 times 1? That's 4. 4 times 2 is 8, so that's 8. So 25 minus 8, that gives us, 25 minus 8, that gives us 17. So 17, our discriminant is 17. In this case, this discriminant right here, the discriminant of this quadratic is 17. So we will have two solutions, but they will not be rational. They will be irrational solutions. And if you go ahead and try to complete the square or use the quadratic formula, you'll see that your solutions, you'll have two of them, but they will be irrational. They'll be irrational numbers. So let's go ahead and get rid of this right here. Let's keep going. So that's what happens if your solutions are positive. So positive in a perfect square means you'll get two rational solutions. Positive and not a perfect square discriminant means you'll get two irrational solutions. Now, what if your discriminant is exactly 0? That means you will have one solution. So just a quick example. Let's say we had x squared plus 6x plus 9 equals 0. And let's go ahead and find the discriminant very fast. So we know our a is 1, our b is 6, and our c is 9. So b squared, so 6 squared minus 4ac, so minus 4 times 1 times 9. What's 6 squared? That's 36. Minus 4 times 9 is 36. Equals 0. So our discriminant is 0. So the discriminant of this quadratic is 0, and that means there's only one solution. There's only one solution to this quadratic, and that solution happens to be -3. And the way I could tell is because if the discriminant is 0, that also means that the quadratic is a perfect square trinomial. This is a perfect square trinomial. It's a perfect square trinomial. And the reason it's a perfect square trinomial is because we can express it as x plus 3 squared. And then if you go ahead and expand this using FOIL, you multiply x plus 3 times x plus 3, you'll get back to x squared plus 6x plus 9. And then if you go ahead and continue solving this just normally, so take the square root, and you have x plus 3 equals 0, and you subtract 3 on both sides, you will have x equals -3. So you just have one solution. So you have one solution, and the quadratic you're dealing with is a perfect square trinomial if the discriminant is 0. So our discriminant is 0, so that's what that means. So now one more thing. What if the discriminant is negative? It's a negative discriminant. That means you will have two complex solutions. And what that means is you will have two solutions that are complex numbers. Remember complex numbers in the form of a plus bi. That means there's an imaginary number involved in there. And just let's take a look at why that is if we scroll up to the quadratic formula right here. So x equals negative b plus minus square root of b squared minus 4ac. So b squared minus 4ac is the radicand right here. It's underneath this radical, this square root. So if what's underneath the square root is a negative number, then taking the square root of a negative number, it will lead to an imaginary number, thus making this entire solution a complex number because these will be real numbers, b and a, and the square root of a negative will come out to an imaginary number. So you will get complex solutions. So if the discriminant is negative, right here, if it's a negative number, that means you have two complex solutions. So that's very important to understand the discriminant of a quadratic, and also that's how you use the quadratic formula to solve any quadratic equation out there. So I hope this video helps, and if you have any questions, please leave them down in the comments below, and thank you for watching.